Hello dear students. So today we are going to start with our integration from calculus, which is considered to be very important topic in class 12 mathematics, because there are many chapters which are fully dependent on integration. Okay, and not only in mathematics, but it really helps you in your physics and chemistry as well. Okay, so without wasting any time, let us start with integration. So in the first line itself, I've written integration is the reverse process of differentiation. Okay, so let us try to understand the physical meaning of this. Now, from the lecture of differentiation, I showed you that differentiation is nothing dividing a particular interval into small sub intervals. Yes. Okay, now in integration, what we are going to do is we are going to sum them up. Okay, we are going to add those small intervals. So we'll try to understand the geometrical interpretation of integration later when we do something called definite integrals. So before we start doing definite integrals, we need to start with indefinite integrals. Okay, so you might be thinking, what is definite, what is indefinite? We'll understand through some example. Okay, so we'll see the examples later, but let us try to understand this meaning of this first sentence, that is the reverse process of differentiation. Okay, now for example, let me consider a function fx. Okay, so there's a function fx, and if I differentiate this function with respect to x, okay, so if I differentiate with respect to this x, then let us assume that I am getting fx. Is that clear? So capital Fx is a function, and when I differentiate capital Fx with respect to x, I'm assuming that I'm getting small fx. Now according to your integration, now if I differentiate this, okay, so if I integrate the function small fx with respect to x, now whenever you write differentiation, you write dx in the denominator, right? But here in case of your integration, you'll write here. Okay, so this means integral of fx with respect to x. Okay, so that means when you integrate this function, you have to get this capital fx. Okay, so whenever you integrate, you'll get the same function back. Now this is still incomplete. Okay, so in indefinite integrals, now indefinite integrals means if we don't put any numbers here and here, okay, this is called lower limit and this is called upper limit. If we don't put any numbers, if we keep our sign like this only, then this is called indefinite integrals. Okay, and whenever we solve indefinite integrals, there always has to be a plus k written. Okay, now this k stands for constant. Okay, so you need to remember this one. Why we are writing plus k, we'll try to understand here again. Now suppose if I differentiate capital Fx, I am getting fx. Now suppose if I differentiate fx, sorry, this capital Fx plus k, let us see what do we get. So we get, this is d by dx of capital Fx plus d by dx of k. Yes, and we know that d by dx of capital Fx is how much? It is fx. And what is differentiation of this? This is differentiation of constant, that is 0. So fx plus 0 gives me fx. That means if I differentiate this, I am getting fx. Yes, that means if I integrate this, I should get back this as well. Okay, so that's why we need to always put a constant. Hope this is clear to you. Now if I draw the graph of integral function, that means from here I saw that my function, my answer for integral of small fx is this much. Yes, okay, and this is also a function. Yes, so if I call this to be y, that is y equals to capital Fx plus k, okay, where y is integral of this one. Okay, so this is integral of fx. Yes, now if I draw the graph of this function, what happens is I'll get many graphs for the same answer. Why? Because there's a function, there's a constant term here, right? So this constant may take any value, so it can be 0 also, it can be 1 also, it can be 2 also. Okay, so if I put k to be 0, then I'll get one graph. Okay, now if I put k equals to 2, I'll get another graph. If I put k equals to 3, I'll get another graph. Okay, so if you see the solution of the integral, this is the integral and this is the solution. So the solution of the integral can be plotted in many ways possible in a graph paper. Okay, so that's why the solution, okay, so the very important point, the solution of indefinite integrals gives me many curves, right? Many curves. So those curves are known as integral curves. Okay, so you need to remember this thing. And one more very important point is integration is also known as anti-derivatives. Okay, so since this is reverse process of differentiation, that's why it is also known as anti-derivatives. Okay, anti-derivatives as well. Okay, hope this is clear to you. Now we'll try to understand the formula. Okay, so I'll show you the few formula and I'll give you a list of formula which you again need to note down in your formula copy. Okay, so that it will be easy for you to use the formula in problems. Okay, and I suggest you to maintain one formula copy for you. Okay, now let us begin with the formula. Okay, so let us write differentiation formula first, because we know that the integration is just reverse process of differentiation, so that's why I'm writing differentiation formula. So differentiation formula, I'll just write a few formula and the rest formula I'll give you in the next page. Okay, so we have differentiation formula and here I'm going to write integral formula. Fine. Okay, so the first formula which we learned, okay, for example I'm taking differentiation of sin x, and how much is this? It is cos x. Yes, and we have differentiation of cos x to be minus sin x. Yes, okay, similarly I'm just taking trigonometric function for now. This is sec squared x. Okay, and I'll take one more last function, that is differentiation of, okay, so let me take sec x. Okay, so it is sec x tan x. So let me take these four formula. Now the corresponding formula, so integral. Now as I said, differentiation of sin x is cos x. That means since the integration is opposite or reverse process of differentiation, so that's why integration of cos x should give me sin x. Okay, as I said, integration of fx should give me capital Fx. Okay, so integration of cos x, okay, with respect to x, so that's why I have to write dx will be equals to how much? It is sin x. Okay, now if I integrate if I integrate minus sin x, then I should get cos x. Okay, so integration of minus sin x, so let me write only sin x, that minus can be taken outside. Okay, so all the constants attached to the function can be taken outside, so minus 1 can be kept outside. So if I want to make it plus, this minus comes out there. Okay, so that means integration of sin x will be minus cos x. Similarly, integration of sec squared x is going to be sec squared x with respect to x is going to be tan x. Yes, and the integration of sec x tan x is going to be sec x tan x is going to be just sec x. Okay, and as I said earlier, we always need to put one constant, so that's why I'm putting plus k everywhere. Okay, plus k. So just pause the video to note down only this much. The rest formula will be given in the next page. So these are the formula that you need to copy, so you can pause the video to copy the formula. Okay, so you need to copy the properties of indefinite integrals as well. Okay, so the first property says that integral sign can be distributed over addition. Okay, similarly in number 2, whenever there is a constant attached with a function, that constant can be taken outside. So pause the video to note down the properties. Okay, now let us solve few problems which are based on our formula. Okay, so the first problem says, so we need to prove the following. That means, what are the values of integrals? All are given, we just need to prove them. We just need to verify that our answer should be this much. Is that clear? Okay, now let us begin with the first question. So we know that whenever there is a plus sign, this integral can be distributed over all of them. So we have integral of ax squared plus bx plus c dx. Now this integral can be distributed over plus, so that's why I can write integral of ax squared dx plus integral of bx dx plus integral of c dx. Okay, now since a is a constant, this can be kept outside, so we have x squared dx plus, similarly we have b is a constant, so it will be kept outside, plus similarly the c is constant, it will get outside, so here we have got only dx. Now we know that integral of x to the power n with respect to dx with respect to x is given by x to the power n plus 1 by n plus 1 plus k, constant of integration. So using this, we have here n to be 2. Okay, so this will be equals to a into x to the power n plus 1 by n plus 1. Yes, so plus this can be written x to the power 1 is there, so that's why n is 1 here, so it will be x to the power n plus 1 by n plus 1 plus c, and we know that integral of dx will be how much? It will be x. Okay, so since we have completed our integrals, so that's why I need to put a constant over there. Okay, now we have a 2 plus 1 is 3, so a by 3, we have x cube here, plus similarly here we have got b by 2 x squared plus cx plus k. Okay, so this will be our final answer. So pause the video to note down. Now next is this problem. So here we have got a negative sign if you are not able to see. Now let us verify this integral. So what am I going to do here is, I am going to first divide with x to the power 4 to each term. So we have a x squared by x to the power 4 plus, okay, so as I said, this integrals can be distributed, so plus integral of bx by x to the power 4 dx plus c by x to the power 4 dx. Okay, so first you have to begin with this. You have to write this equals to this much. Now let us see the cancellations which can be done here. So from here I can see that this x squared and x to the power 4 can be cancelled, so only x squared will be left. Okay, similarly this and this will be cancelled, so x cube will be left. Okay, so in such cases what happens is this x to the power 2, that x squared, goes to the numerator and it becomes x to the power minus 2 dx. Okay, and since a is a constant, it is kept outside. So similarly plus is there, so b is outside, and we have got 1 by x cube, which is x to the power minus 3 dx, plus the c comes outside, so we have x to the power minus 4 dx. Okay, so again we are going to put the same formula here. So we have a into x to the power n is this much, so n plus 1 by n plus 1 plus b into x to the power n plus 1 by n plus 1 plus c into x to the power n plus 1 by n plus 1. Now since we have finished our integration part, so we'll put a constant of integration here, right? Okay, so let us simplify this further. So we have x to the power minus 1, right? So x to the power minus 1 can be written as 1 by x, and minus 1 plus minus 2 plus 1 is minus 1, so it is actually minus. Okay, so minus 1 gives me minus, a is in the numerator and in the denominator this is x to the power minus 1, so that's why this can be written as 1 by x. Similarly here minus 3 plus 1 is minus 2, so plus into minus is minus. Okay, so in the denominator we have got 2. Okay, so in the denominator we have got 2. Now we have got x to the power minus 3 plus 1, that is x to the power minus 2, so when it comes to the denominator it becomes square, so in the numerator we have got b. Similarly this is minus 3, so plus into minus becomes minus, and in the numerator we have got c, and in the denominator we are going to have this is 3. Okay, minus is here, so 3 is left, and this x to the power minus 3, when it comes to the denominator it becomes x cube plus k is there. So if I take out minus common from here, then I have minus a by x plus b by 2x squared plus c by 3x cube plus k. So this is our answer. Okay, so pause the video to note down. So before we see the next problem, number 3, there's a formula in logarithm which says b can be written as a to the power log b with base a. Okay, so we need to first learn this formula in order to solve the next sum. And as I said in the beginning, that in calculus whenever we see only log, the base has to be e, right? So here also the base is a, and here this is also a. Similarly here also it is e, here also we have got e. Okay, but in front of log there is no number. So therefore what I can do here is, so I am writing this equals to, so we have this can be written as e to the power log x to the power m, because this m ultimately comes front, and so that I'll get back the same thing. Now this is like b for me, this is my a for me, and base is also e here, right? So that's why this can be written as, so this can be written as how much? This can be written as x to the power n dx. And we know that the formula for x to the power n dx is x to the power n plus 1, and here n is m, so m plus 1 divided by m plus 1 plus some constant of integration c. Okay, so this is how we prove the problem. Okay, now next is this one. Now whenever you see such kind of problems, okay, where you have got a fractional kind of stuff, try to see whether there is anything common. Okay, and if there is anything common, just take them outside. Okay, so we have 3 as a common, right? And similarly e to the power 2x can be taken common. So from here only 1 is left. From here how much is left? E to the power 2x is left. Okay, now since all the powers are positive, let us try to make this also positive. So this can be written as e to the power x plus 1 by e to the power x dx. Okay, now we have, let us simplify the denominator. So we don't have any problem with the numerator, so let us simplify denominator. So this 3 can be taken outside integral sign. So we have e to the power 2x 1 plus e to the power 2x by e to the power x into e to the power x is e to the power 2x plus how much is that? Plus 1 by e to the power x dx. Okay, now this e to the power x inverts and goes to the numerator. So this in turn can be written as e to the power 3 e to the power x, and e to the power 2x gives me e to the power 3x 1 plus e to the power 2x by e to the power 2x plus 1. Now since these two are same, so that's why they gets cancelled. So what is left? It is 3 into e to the integral of e to the power 3x dx. Now what is integral of e to the power mx? Integral of e to the power mx dx is how much? 1 by m e to the power mx. Yes, and here m is how much? 3. So that's why it becomes 3 into, okay, so integral of e to the power 3x is 1 by 3 e to the power 3x plus some constant of integration. So this 3 and 3 gets cancelled, so my answer will be e to the power 3x plus c. Okay, so pause the video to note down. Okay, so let's go to the next question, question number 5. So as usual, what am I going to do? Since there is a plus sign, I'm going to distribute this integral sign over addition. So we have 1 dx, which can be written as only integral of dx plus integral of cos 2x dx, right? So this integral of dx is x plus, now we know that integral of cos mx dx will be how much? It is 1 by m sine mx. Okay, so if I put that formula, my value for m is 2, so that's why it will be 1 by 2, and the integral of cos will be sine mx. M is 2 here, so 2x plus constant of integration, which is c. Okay, so this is our answer, which is directly based on our direct formula. Now we'll see the last problem. It is a bit longer, okay, but the question is same. Question is easy. Now let us take the left hand side. So left hand side can be written as, okay, so as usual I am going to distribute integrals over every sign here. It is plus and minus present here. Now if I distribute this integral over 3x squared, then this 3 can be written outside, so x squared dx is left. Similarly from here 7 can be taken outside, so we have integral of 7 e to the power 7x dx plus this 5 can be taken outside, so we have dx by x. Yes, okay, plus 3 integral of sine 3x dx minus 4. Okay, so we cannot distribute integrals over multiplication, you need to remember that. Okay, so we have cosec 4x cot 4x dx, right? Okay, so this is x to the power n, so this is 3 into x to the power n plus 1 by n plus 1 plus 7 e to the power mx, so it will be 1 by m e to the power mx, yes, plus 5. Now integration of 1 by x with respect to x, that is integral dx by x is how much? It is log of x. Yes, why mod sign? Because within logarithm we always need to have a positive quantity, so that's why I'm putting a modulus over there. So 3 into integral of sine mx will be minus 1 by m m is 3 cos mx, that is 3x, right? Minus 4. Now integral of cosec x cot x. So this is equals to how much? It is minus cosec 1 by m. M is 4 cosec mx, that is 4x. So since we have finished all the integration, so that's why I'm putting a constant of integration. So 2 plus 1 is 3, so this 3 and 3 gets cancelled. So what is left here? So only x cube is left. Similarly, this and this gets cancelled, so plus e to the power 7x is left, plus 5 log of mod x. Similarly, this 3 and 3 gets cancelled, so plus into minus is minus cos 3x. 4 and 4 gets cancelled, so minus into minus is plus cosec 4x plus c. So this gives me the answer. Pause the video to note down. Okay, so although we are doing indefinite integrals, side by side we'll be doing definite integrals as well. Okay, so let me give you a brief introduction about your definite integrals. So there's a chapter on definite integrals later in your book, but we'll get introduced now itself. Now this is a fundamental theorem of calculus. Okay, so the statement is given to you, so you can pen down the statement. Okay, but it's better to understand the statement using examples. Okay, so for example, I'm going to take one question. So the question is, show that okay, so let me call this as number 1. So first question I'm writing is 0 to 1 x cube dx equals to 1 by 4. So let's try to understand this. Okay, so if I compare these two, the value of a is 0, okay, and this is known as lower limit, and the value of b is 1. So let us try to solve this problem. So here my fx is how much? Fx is x cube. Okay, now when you integrate this function, so according to this, which we have already seen in the introduction part, if you differentiate capital F, you are getting small f. That means if you integrate small f, you'll get capital F. Okay, so let us integrate this first. Okay, so we have integration of this one to be how much? So from here, integration of fx is going to be integral of x cube, because my fx is x cube dx, and according to the formula, this is x to the power n, so that's why it will be x to the power n plus 1 by n plus 1. Yes, okay, now this is equals to x to the power 4 by 4. Okay, and we need to put a constant of integration as well, right? Okay, so the value, okay, so let me take this one. So we have 0 to 1 x cube dx. So what is the value of this integral without the limits? It is x to the power 4 by 4 plus k. Yes, so this is my, actually what, this is my, after integration, whatever I get is my capital fx. Okay, and according to the formula, my answer has to be f of b minus f of a. So what is f of b? Let us calculate. What is b for me? B is the upper limit, which is 1. So f of 1 is, let us see how much is this. So f of 1 is 1 to the power, x is 1, so 1 to the power 4 by 4 plus k. So what is 1 to the power 4? It is 1 by 4 plus k. So this is the value of f of 1, and let us see what is my f of a. And what is f of a here? A is 0, so that's why instead of x I am going to put 0. So it is 0 to the power 4 by 4 plus k. So this quantity is 0, so only k is left. So that's why let us see what is fb minus fa, that is f1 minus f0. So it will be equals to f of 1 is 1 by 4 plus k minus, what is f of 0? F of 0 is k. So this k and k gets cancelled, so what is left? 1 by 4. So my answer has to be 1 by 4. So all the time I cannot do this way. This is going to be a lengthy process. Okay. So what I can see here is, if there is limits given, upper limit and lower limit is given, that means indefinite integrals, our answer is free of plus k or plus c, that is constant of integration. Okay, so if we can see that, then it's not necessary to write plus k every time. Okay, so what we need to do is we'll first integrate. Okay, so after integration, whatever we get outside that, we'll put a bracket like this. So we'll put lower limit here and we'll put upper limit on top. Okay, so what we next you're going to do is, so we'll put the value of upper limit first. Okay, that is 1 to the power 4 by 4 minus, we'll now put the value for lower limit, that is 0 to the power 4 by 4. So how much is this? This is 1 by 4 minus how much is this? It is 0. So my answer is 1 by 4. So this is how we solve the sums on definite integrals using fundamental theorem of calculus. Okay, so pause the video to note down. I'll give you some questions in the description to practice at home. Okay, so pause the video to note down. Thank you very much.